Right. Welcome everyone to Omaha Data Science Academy. This is a fall 2025 version of SQL 101. This is class 5, cleaning data using SQL. So in this class, you're going to take all of those skills that you've learned in the first 4 classes and apply those to cleaning up messy data in tables. So you would say, well, why is there messy data inside of tables? When you're putting constraints and you're only allowing certain values into fields, or certain ranges and everything like that. And there can be a few reasons. One of them is just the data is not the way that you need it for your analysis, so you need to clean and format your data. Maybe it's a form that customers are filling out that they misenter some information. You're giving them some options, but they just misenter their information, or they do inconsistent formats with their phone numbers or email addresses. Or it could just be some kind of system error, some type of redundant data. Maybe something was accidentally deleted from a customer record, or maybe 2 parts of the system have 2 different versions of someone's address. It's like, how do you use all of these skills for like these real life things that you'll see in actual systems that you as a data analyst will dig into, get data out of, and then provide reports and data and insights out of. All right, so this tends to be one of the more popular classes because you get to be the data analyst. So you're actually not just learning, but applying all of these skills. Okay, so the first hour, how this class is structured, first hour is cleaning data, the importance of it, SQL wildcards. So how do you find like text strings within, or like substrings within pieces of text? Really important to be able to identify small things in their cleanup parts, or identify different types of text values. And then identifying and removing duplicates. Nothing hurts an analysis more than having duplicate data in your database tables. And like you'd say, why would that happen if you have a primary key on your table? It could be that there's just a customer that you're accidentally counting twice or something like that. They created 2 accounts and you end up counting them twice when you really want to count them once. So being able to remove duplicates from any analysis is a big deal. Data cleansing, this will be more for like data cleansing and data formatting. We'll format strings, numeric data, date functions, so the way that we need them to be structured for analysis. Sometimes they're stored in databases as strings. They aren't always in the prettiest format. They're in the format of whatever the system reads or the developer needs. Even numeric values or date values. So converting those to something that you can use for analysis. Hour 3, we won't actually have a homework, but we will do examples of cleaning data for analysis. So the homework will come, next Monday, after containing content from this lecture and the lecture that we'll do on Monday. It'll be assigned Monday at the end of class. Okay, so quick review of class 4. We covered a lot of ground in class 4. This is where SQL becomes more conceptual. You really are working to visualize how you're bringing 2 different tables together in different ways. So we learned about joins, the different types of joins, or different ways you can bring tables together based on matching values or key values. We learned about left joins, inner joins, right joins, full outer joins, and everything in between. Unions are where you can append data, and you can do it with or without duplicates. And then we learned about subqueries. So you can actually write a query and put it within another query and use the results. And that's useful when sometimes it's difficult to write everything in a single query or try to create all the logic. One example is where you want to do some, when you have two different aggregate levels in a query, maybe you want to do a subquery that gets you the total over the entire table and then bring that into the main query. We saw that in a COVID example in the last class. But there are a number of reasons why you could do it, using it in where or even select clauses. That's definitely one. If you don't still get it, just go back to the videos, go do lots of practices, go out to the web, and do some of those interactive tutorials until you really start to see it, until it finally clicks. And then the homework will have, especially the basics homework, will be world tables that we did pretty similar examples to those in class. So maybe a good place to start, and then challenge yourself with the more comprehensive, homework. If you get through that once that clicks.
Yeah, this is what I was confused. I just go ahead and kind of wrap around the SQL joins.
Yep, don't give up. One of my stories is that I was in college a long time ago, and I was in a calculus class, so it was a hard class. And I just couldn't get this concept. I was working at it, and I even went for help. I was worried. I'm oh man, the test is coming up, and it just clicked right before the test. I just kept working at it. And that moment it does, it's at least someday to me, it's exciting when that happens. You're oh yeah, I finally get it. So just stay at it. Like I said, use ChatGPT or Claude to help you out if you get stuck. I just didn't back then. I didn't even have those examples. You just had your textbook and maybe somebody to teach you. Not even really that many online videos or anything. So use your resources. If all else fails, of course, reach out to me. See if I can help you out. So this lecture will move, since you already have the basics, it is, there's a lot in this lecture, so we're going to move fairly fast through it. And if you don't get it the first time, don't worry. Focus on getting homework done first and all the concepts there, and then this one will fall in place for you a little bit more. Okay, so we kind of talked about it, but class 5 objectives, SQL operators, wildcards so really cleaning up text strings, how we can do that. You use case statements and logical functions. Case statements sometimes to clean up fields or apply business rules to a field that makes sense for analysis. Maybe there's a business field that's just the values are A and D and T and V, and they don't make that much sense from an analysis perspective. If you're an analyst and you do a dashboard or a report, they aren't going to make that much sense to the end user, but maybe you add a label to it. You add a label for B, business or something. You create labels for all these different values. That's one way to clean it up for analysis. Or just purely cleaning up data. Case statement can work for that too. Logically, we're going to use lots of functions. Functions will be your friend in cleaning up data the way you need it for analysis. Removing duplicate data, we said the importance of that. And cleaning and formatting strings, numeric, and date time data. I spent a lot of my life doing that. Almost feels like too much, but huge part of being a data analyst.
Data time.
Yep. Yeah, so we'll see it in this slide. I just created this slide for this class, but common data quality issues. Imagine this is a table that you're looking at. You have all sorts of things like duplicate rows. You have like John Smith multiple times in your account table. You have it where John Smith is lowercase and then John Smith is capital, where he put his phone number in a different way 2 different times. It can happen. Then you have null values, and you say, should we just keep the null value or do we need to do something with that? So a whole bunch of things here. The most common data quality issues, and I think this captures it pretty well, is inconsistent capitalization. It breaks matches. So doing John Smith or New York City. We'll learn how to handle that. Technically, usually what I do on capitalization is just make it all the same case. You have leading and trailing spaces. Sometimes these are impossible. So in computer language, or impossible to just see from looking at the data. Imagine one of these just has a space at the end of the name and one doesn't. It doesn't seem like a big deal in computer language. Those are 2 different names. We'll use some functions for cleaning up strings, leading and trailing spaces. You can do trim functions. And you have some null versus empty string confusion. So this is where the idea of null and empty is 2 different things. Like null would potentially be like it doesn't exist. But maybe it should exist. Maybe it's just missing, or it's an empty string for some reason. So cleaning that up for analysis and figuring out what to do with those null values. All these duplicate records, if you were doing a customer count, you would count John Smith 3 times, even though it's really 1 customer. Working with that, mixed type phone numbers. Phone numbers and addresses and email addresses are some of the most painful things you'll ever work with. Getting those into consistent format. Maybe you're creating a customer list for your boss or for the sales team. And numbers stored as text that break calculations. So they might store, this is a good example, zip code. So oftentimes you'll want to store zip code as a string because you want to keep the leading 0 on it. Otherwise, if you keep it as a number, if the zip code starts in 0, they'll drop it off. But what happens if somebody in the system accidentally put an A at the end of their zip code or something like that? You try to convert that over to an integer, or you try to convert it to a number, and then it doesn't work. So if you were converting zip codes to a number for whatever reason, a better example is probably a part number. If it's a number most of the time, and then all of a sudden you have alphanumeric, you're trying to convert it to a number for whatever reason, then you get an error because of it. Like some things that, like when you try to convert those text to a certain data type, that it breaks. We'll see how we can handle those more effectively. And I do think that those are the most common data quality issues, just purely with the data itself. So cleaning data, and so this is part of being a data analyst, is that there are 5 data quality dimensions. You have validity, making sure all of those values have the correct format and they meet the defined rules and constraint, that you aren't just producing random values or values that don't make sense. Accuracy is correctly reflects the real world values it represents. So we saw in lecture 2 where we put a constraint on the table for credit limit. Like if you had a credit limit of 10 billion, then their data is probably not that accurate. Completeness, all required data fields are present with no missing or null values. There's sometimes reasons why you have null values in a field, like a non-existent values. But I do say this because with data science models, a lot of the models, machine learning models you create, they don't accept null values as part of like building the model. So oftentimes and even if you're if you're a data analyst and just looking through data, you'd ask, like, are these null values legit? Should they really be like missing or null values? And then how do we handle them for the analysis that we're doing? Consistency, data matches across systems and there are no contradictions. That would be where you'd have John Smith and his name would be the same across all the systems. So you have John Smith instead of having like John L. Smith, who's the same customer. If you put a middle name in there, or you have them multiple times in different places. In data engineering and data strategy, there's a thing called data governance that puts those type of rules around data so that you're producing as much consistent and accurate and complete and everything, but it definitely, especially consistency. And then uniformity, the data uses the same format, units, and standards throughout the data set. So probably where that fails the most is if there's a change historically, like data was stored one way historically, and then it starts to be stored a different way than you're used to. Be a data analyst job to reconcile that, the uniformity, and then how you want to handle the previous history and then the new history going forward, making sure that the data is uniform. And I put this pie chart here because it's the truth. But what's the least enjoyable part of data science? So think of these as data scientists. They want to build like all the coolest stuff and show off and whatever else. They say cleaning and organizing data is 57% of them find that the least enjoyable. And I'd probably also put along that 21% of collecting data sets. Collecting the data is also like you collect the data and then you clean the data. It kind of somewhat all goes as one. But that's where data analysts can make their living. So if you really like diving into data and understanding it and cleaning it up and then present it or like getting it to where you need to answer the question or that analysis that you're going to do, you would potentially love doing this stuff. That's where data analysts make a living. Yep.
So the cleaning and organizing data or data is more enjoyable? Is that what people are saying? Or is that
data science, or a lot of people hate it.
Oh,
But that's where a data analyst, makes their living. They said the least enjoyable part of data science. Yeah. Because they're like, well, I wish I was building all this cool stuff and algorithms and creating AI models and stuff like that. I don't want to spend all my time cleaning and organizing data and stuff like that. But that's where data analysts makes their living, is understanding data and systems and process and what the value should be. And then helping turn data into the information that you need. Okay.
sort of like what we did with Tableau.
Yeah, I do a lot of this in Tableau. I also oftentimes will load a data set into Tableau and I'll see issues with it. And then it'll help me clean up the data the way I need it. If you guys did something like that in Tableau, I often clean data in Tableau and then write some SQL code and put it in a view or do whatever I need to. It helps me Tableau will help me find all of the data issues inside of it potentially in a faster way. So yeah, you could quickly summarize on a field and see all the values and the counts and like if there are any weird values in it and stuff like that. So oftentimes I would use Tableau alongside SQL. I load the data and then write all the cleaning rules that I need while I use Tableau to work through the data. That's just my preference, but you could do it in Python or different ways, or write code in SQL to do it too. So the goals of cleaning data: number one, removing those unwanted observations, whether it's duplicates that bias your analysis or irrelevant observations and outliers. You're doing that a lot in data science. So you're removing observations that don't have any values or they have weird outlying values. It's also part of a data analyst role is to kind of identify like things that are going on that are weird, that's weird in data, and then ask how to correct it. And you can do that using SQL, potentially. Fixing structural errors that occur during measurement or data transfer. Multiple ways to spell a word or mislabeled classes. So in measurement, maybe data is being collected and it's not always consistent or in a perfect format. Fixing some of that structural error is data analyst jobs, understanding the data and fixing it for analysis. And then handling missing data, like we said, either oftentimes you'll drop it. Imputing is understanding and figuring out what value should go into it if it's missing. So that's where case statement could be really valuable. Maybe there's some rules, and based on the other fields, you know what value to put in for the missing, even though it's missing. Or maybe you have business rules to, whenever you have a null value, you set it equal, it's an actual zero, so you set it to zero. We'll have functions to do that, but it's really starts to become up to the analyst and the analyst's expertise on, you'll have the tools and be able to write the code using SQL, but it's also the data analyst job to understand the data and understand why the data is the way it is and it's not clean, or the format it needs to be for an analysis, and how do you get it to where it needs to be. So we're going to start by focusing on how we work with text. So what I use really frequently is the SQL-like operator, particularly in the where statement. These are called SQL wildcards. And a wildcard character is used for comparing and or substituting one or more characters in a string. So we're going to present these and we're going to do a couple of examples on the next slide. But I use the % the most. So the % would represent 0 or more characters. I think these examples over here help you out. So 0 or more characters. So you have these first two characters, they start with BL. And then it's any number of characters after that. So if you have a string, it's looking for any string that's first two letters are BL. It can be anything after that. But consider what that might be able to find. It'll find BL. If that's a value, it'd find both black and blue. And then blob, if blob was in there, if it wasn't a color. Because it just looks at those first two characters and anything after. One of the things I do the most using a like statement is that I'll put it on both sides. And it's like finding a substring within a string. So if I did a %, AC, and then %, it would ignore these. It'd be anything before the AC and anything after. So it's really like a good way. I use % all the time to try to find substrings within a larger string or character value within a database table. So I also use some of these other ones too. So underscore represents a single character. So if you had H in the first position, in the second position, that could be any character, but it's a single character. And then T in the last character, that'll find hot, hat, and hit. Because there'll all be 3 links. In the first position, it'll be H, can be anything in the second, and then T in the third. It's exactly 3 characters long, and that's why you have H and T at the end of these and anything in between. You can also do a series of those. You can put a bunch of those together, and or like any combination of wildcards, which we'll see. Okay. So the brackets are like specifying, it's similar to that what we just learned, but the brackets specify any single character within the brackets. So now instead of just saying any character, we say only the O and the A's. So it'll still be 3 characters long because first position, anything in the brackets is the second position, and T is the third position. So you'll get hot since O is in the brackets. You'll get A because that's in the brackets, but you will not get hit because the I is not within those brackets. Then you have carets. They represent, that's what they call those. That character, it is above your 6, number 6. It represents any character not in a bracket. So it's like, it's kind of like a logical not. So you'd have this, and it makes it like not O and A. So this now will find hit because first character and third character and I, it's not in O and A. And then it will not do hat or hot or hat now. So it's just taking this and making it not that, which is just the opposite. So the caret just makes it like a not. So it does not want O and A to be in the second character.
Oh, okay.
So now it finds that hit because I is not in the O and the A. And then it excludes hot and hat. That might be useful. Maybe you're excluding certain states or something. You say in the first character, I don't want any states to start with them.
So in SQL,
yep.
Would it always be states, or it could be anything?
It could be anything. This is any type of text. This is just some operators that you can use to manipulate string values and clean up string values. And then the dash represents a range of characters. So the C would be the first character, and anywhere in the range A to B. And the last character is T, character 3. So it'd find cat and CBT. And nothing else because it's in that range. There are a whole bunch of wildcards. I think I just put the 5. I would use these like 99% of the time. Occasionally, you'd have some wildcards and what they call regular expressions in programming languages to do all sorts of things with text. So these are common in programming languages. But you can go to see this SQL wildcards link for a much more broad list of wildcards and examples of how you could use them. W3 Schools is the best for that. Okay. So let's do some of these examples. Go ahead and pull up.
So when you say SQL wildcards,
yeah.
Is that just for the sake of illustration, or is there actually a SQL wildcard?
That's kind of what these are called. These percent signs and dashes and stuff like that. It's kind of like, I guess, a wild card. Like if you had a wild when you're playing cards, it can do like, it's a card that could do like a bunch of things. Except these do like specific things. They don't refer to just a single letter. Okay. Let me bring up my SQL workbench and do some work in here. Ask me questions as we go, whether it's in Slack. I don't see any there so far, or I'm a bit slower at getting to the questions in StreamYard, but I'll do my best to get there too. No problem. Just trying to make this one the right size and then bring over my SQL workbench. My screen's a mess here. Just 1 second while I bring over a workbench and resize this thing. Size this thing right. There we go. Get up there. We'll open the PowerPoint SQL file. I already have it saved in here. Maybe you do too, where you can go and get that off of your desktop or wherever you store it. So you can scroll down. We'll have some lecture 5 examples. Okay, here we go. It starts here. Slide 7. I've done some different work to the slide, so it may not be the exact slide numbers, but these are the same queries. So let's just do this. Let's run the first part first. We're just getting the names of all the countries out of the world.country table. And we can imagine what AIN would do. Or let's scroll down here. So we have the like operator where we can use wildcards. And we have where a.name is like any characters, then AIN, and then the percent at the end, anything afterwards. So the first thing that comes to my head is Spain. So it can be SP at the beginning and end in AIN, and the percent sign is fine at the end of it. If it gets to the end of the string, then that's okay. It doesn't look for any characters afterwards. But let's see what happens when we run that. It'll also include countries where there are any number of letters. There's AIN and anything after it. So let's see what this comes up with. I thought of Bahrain too. But check this out. It has like Santa Lucia because the percent, it's like anything, and then the AIN, it finds AIN in the string, and then it's anything afterwards. So super valuable for finding small little, it's kind of like a search. I want to search all of these values that have AIN somewhere in it out of all these values that you have in the column in this text values you have in the column of this table, and then return me those results. Okay, so we also have, this one's fairly obvious, but select the name and then country code for world.city, where name is like underscore London. So this is going to do any first character and then exactly these characters after it. Since we don't have a percent sign, it's just going to do 1, 2, 3, 4, 5, 6 with anything at the beginning. So there's actually in the database a London, Great Britain, and London, Canada. So we'll get both of those. And you can be really creative. You can use anything that's 5 characters long. You can mix like any combination of these. These are all the cities that would be like exactly 5 characters long. Oh, let's do something. It starts with something. And then it's any number of characters. Let's do like NE. Then anything could be in the following 2 characters. And then anything after that. Let's see what this gives us. Say NE, then it looks at any values in the next 2 characters. And then anything after that. So you have like Newcastle, Newport. Or you could do even NE, any letter in the 3rd character, 4th character is P, and then anything after that. So as Newport and Newport News, Virginia in the United States, Newport, Great Britain. So you can use any combination of these wildcards with letters to be able to find the strings that you need. So super powerful. MySQL, if you find that you can't do what you need to in the like, which to me is pretty rare, even as like a data scientist, it covers like 95%, but it does have this function called regular expressions that you can look up on that website on the W3 schools. So this would say name country and world.country, where the name regular expression, it has the carets, BSP. So it says find all countries starting with B, S, or P. So this is a little bit different than you saw on the previous slide. If this was inside of this, you would say not BSP. So what this caret, the regular expression does here is it looks at that first character and then anything that's BS or P. So the regular expressions are a little bit different than the likes. How it works in MySQL. But it returns all of these countries to start with B, an S, or a P in the database. So what if we did, I think that should negate it if I do that inside of there. So all countries that do not start with B, S, or P. Let's see if that works. Yeah, so we have A's, no B's, and then you have the C's. So if it's inside of these brackets, that's a not. But if it's outside of the bracket in regular expression, it's just indicating the position in the string.
Outside indicates the string, inside indicating not or null.
Yeah, if we did this, then it would be not B, S, or P in that character position. So a 10 that you can do with these regular expressions are built to its programming language, so they do anything that you'd ever need to do with strings. If you needed to go to regular expressions, I'd say 95% you can do it with likes. With the like operator and then those wildcards that we talked about. Okay, so let's get through the remove. We'll do the removing duplicates and then we'll take a break. So we'll look at removing duplicates next. Go back to presentation mode. Okay. Removing duplicates. The purpose is improve the accuracy, consistency, and uniformity of data. Removing those identical observations that appear more than one time in the SQL table. So keep in mind, as a data analyst, there may be a reason why something appears more than once in a table. So you don't necessarily want to remove the duplicates, but you can remove the duplicates by identifying them and then writing code to be able to do it. So we're going to learn 4 different ways of doing this. I just added one today. We have a select distinct keyword. So we learned that in the second class, just as a keyword. We didn't use it a whole lot. But if you're getting a single column and it has 100 records and you have duplicate records in each one of those, it'll just get you the distinct values that are in that column. So say you have 10 values that are distinct in that column and the rest happen any number of times, it'll just get you each one of those once. That's often a way to clean it. Distinct is often important when you're doing counts and sums also, that you're counting like the right customer IDs. You aren't multiple counting customer IDs and things like that. Duplicates by key, we'll see how we can use a subquery to be able to see how many times a certain value appears in a column or combination of columns. We'll do duplicates by aggregation, which is the same thing. You could summarize it once you do that. And then duplicates by row number. So this is a new one that I included. So if you do use a function, there's a row number function in SQL that you can use, and you can do a group by, which counts the records 1, 2, 3, 4, 5, and so forth within each group. We'll see how we can use that to remove duplicates. So there are a few different ways to identify and then remove the duplicates. And then it's up to you, like I said, as a data analyst, to determine the best way to do it, or if they even should be removed or not. And also, what do you need for your analysis? What should you be counting for your analysis? Okay. So let's identify some of these by aggregation. We aren't even using a subquery in this one, so it's not by key. We are just summarizing by a column or a group of columns, and then doing a sum to see how many times they appear. So this is we were just talking about right at the beginning of class, that using Tableau for exploring data and seeing like what values appear in there, and if there's anything weird or missing or duplicates and things like that. So this is actually like really similar to a Tableau view or a Tableau view you would create. You would just drop the city field in there, and then you would do a count. And then you'd say any of these values that have a count greater than 1, it's just not a single value in that row. It would be a duplicate value in that row or group of rows. So you could use city and state, and maybe for whatever reason, if there's 2 Columbus, Ohio's, city, state was Columbus, Ohio, and it's 2, you'd probably want to dive deeper into that and see why it's repeating. Or you can identify it even if it's more than one column. I'll show an example, try to show an example of that. But let's go ahead and go to our code examples. Okay. So identifying these by duplicates. Name city. You have the district. So I actually put district in here to see if there are any duplicates by city and district in the world.city table. And the having, remember, after you do your summary, you can filter by an aggregated count. But let's just see. Let's run this part. This is like a where on your group by is what the having clauses. Okay. So we have all sorts of these as one, as you would expect, right? Let's see the first time. Because almost all of these are going to be their own cities and districts. One thing that you could even do, I do this sometimes, you can order by the label that you create inside of MySQL that's specific to MySQL. Oops. Oh. Other work that I'm doing. Let's order by count descending. So this should order the counts from high to low. We can find some here. We found a few duplicates. San Juan, Hamilton and the Hamilton. And that must be from China. So you could also do a sort, but you can also do the same thing using having. Because it's going to take wherever it's filtering on this counter, it's a where clause on your aggregation. So wherever your count's greater than 1, and then in all the other relational databases, it allows you to do this too. Having a sum greater than 1. So it returns those that we're looking at. And then I would be curious, like, I'm not sure why that would be the case. So maybe at the end of this, I just want to see the whole record. It won't want me to do that, will it? Maybe it won't let me because this. Yeah. So I kind of want to dig into these records. Why wouldn't that work? Since I have an error. Okay. So let's do just add some other fields. What are some other fields in that table? Or actually a better way to do this. Just thought about it. You could add some fields and explore that. Or you could take a look at those values, put them in another query, and just do a where statement on it. Do a select star. From world.city, where city is equal to San Juan, and district is equal to San Juan. I have no idea why this would be a duplicate, but we are about to find out. Oops, what did I do here? From world.city, it says unknown column city and where clause because it's called name in that table because it doesn't have the alias there. Oh no, it does here down. Oh yeah, because we're working on this one. I think I actually just rewrote that because I do the same example on a different one. So Mike, I'm curious as a data analyst. So you have a San Juan, Argentina that's in the San Juan district, and you have the San Juan, Puerto Rico that's in the San Juan district. So you actually have those in two different countries, which makes sense. But if it's an actual error, maybe they just accidentally the same exact record is in the table. And then you would decide how you want to handle it, which one you want to get rid of, or if you need to fix it for some reason. It's a way to identify duplicates. And that's doing it by aggregation. That's why I love Tableau so much. You could do this in a database, but you could easily do this in Tableau. And then you click on the count and you view the underlying details, and it tells you everything too. So you can do it visually or writing code. Sometimes you'll still do this. Your data's in the relational database, so you'd write code like this. Okay, so identifying duplicates by key is where we add a subquery in here. So it's the same, you're still doing that same middle part by aggregation. Yep. So this middle query, the inner query, or the subquery, we call it the inner query, and the outside is the outer query, but it's a subquery. It's just summing the names of the city from the world city table where the country code is name and grouping by name. So it's getting this table, all the cities in the United States that have duplicate city names. And now, since it's a subquery, your name is your key. And you give the subquery an alias as B. And then you can join the subquery that we named, that field we named city, on the name of the city in the outer query. So that just describes it. So let's really step through this to think about what it's doing, both on the inside and the outside. Yeah, in the last lecture we learned about subqueries. So we always work inside out with subqueries. We do that. And then we have these unique names. So we can use that as a key. Think of that subquery as just a table or result set that we generated. And then we could take city, because this is just a subquery in our from statement. It's like a table. And then we could join that back to the world.city table. So you'd say, join it, our outer query is A. Our inside query, we gave it the name B, and we reference it, our key by B.city. This, and we join it back to that outside query. And you'd say, why would you do that? This is just another way of how we were doing the last query. It says, I found all these cities with a count equal to 2. I want to look up those cities in the main table. I want to join it back to that table on that key and then get all the information for those records. So then we run the outside. We get the information on all those records. So we see from our other one, we had Arlington. Let's see. Let's try to remember some of these counts. So we had Springfield like 3 times. Columbus, Kansas City, Arlington. Springfield was the one that we had 3 times, and then we had everything else 2 times. That's around the whole thing. So we found both Arlingtons, both Auroras, both Columbuses, both Glendales, mostly both Kansas Cities in 2 different states, Pasadena, Peoria. And then you have Springfield, Massachusetts, Springfield, Missouri, Springfield, Illinois. So it's a way to first on the inner query or your subquery, find the records that are duplicates based on what you're grouping by. And then you take that field or those fields, it could be more than one field. You could be joining on more than one field. Get all the information, all the columns from the world.city table, where that city table matches those cities that you found duplicates for. So I use this one a lot to find duplicates all in one query. So either way, you could use this one or the one before. I do kind of like the just doing a sum and then a sort by descending. But there are a number of ways that you could find duplicates in your data using code, SQL code. Okay. We are closing in on break time. Okay. So we identified duplicate keys. Using this distinct keyword is just as you say, removes US cities within the same, with the same name, the duplicate records. So you can think of this as like when we did union all and we had duplicate records after we appended both the tables together. And then a union would eliminate all those duplicate values. So often when you're doing data analysis, you have to consider if you have duplicates in your data and then if you do or you don't want them in your analysis. If you don't, you could use the distinct keyword. So if we were to do something like removing the United States cities with the same name, right? Because we're looking at this table and we know Arlington appears twice, Aurora appeared twice, even Springfield appears 3 times. If you do select distinct, you use the select distinct keyword. Notice that it's no longer repeating those duplicate values. So sometimes you just, no problem. Sometimes you just want, like if you're creating a list, you just want those single values within the list. Also consider it's part of what your group by statement also does. So if you're summing, and doing the group by, it just compresses all the same values down into one value, and it does a sum or an average or a count over whatever those groups are. So here, if you just said, select distinct name, sum of 1 from world.city or country code USA, and then group by name, it'd be this exact same thing. And it would just have your counts of the number of times it would happen. I would use distinct on a column when I'm just trying to get all the values out of it. Like I'm just trying to understand the column or groups of columns together and all the unique values that are involved in it. Also do that in Tableau too. So many things that you can do there. Yeah, so many things that you can do there, and you can do counts and count distincts there also. And underneath the covers in Tableau, it actually writes code that's almost identical to all of this that we learned. It's just now you can do it with the SQL programming language to explore a table. All right, and then there was one more, and I didn't create the slide for it, but I wanted to cover duplicates by row number And I think we've been going for an hour, so we'll take a break and we'll come back and I'll have that example ready for us. And then the rest of the class, instead of working with strings or duplicates, we'll start formatting values and filling in null or formatting values like decimals or integers, or doing different types of formats on numbers, but particularly dates and times is one of the biggest things that you'll always work with. And we'll learn about the cast function, where you can take a field and then turn it into a different data type as long as it's convertible into that different data type. So let's give everyone I give everyone a 15-minute break. I need to get more caffeine. But yeah, it'll be formatting and dealing with and filling in null values. And then we have a case statement that you can use a case statement to run multiple cleaning or formatting functions on. So yeah, let's come back 7:45. I'll have a couple of examples. Also, hopefully I'll have an updated, I can find the updated PowerPoint SQL file for you so that you'll have all the most current code for the class with like the right slide numbers and everything on it. So
I was going to suggest, so this is Maria Teresa, and I am a data analyst, but I do it all in Salesforce. And I was going to suggest that, so I've started doing Power BI and using the DAX. And one of the things that I do, which might be helpful for other people, is I do a lot of stuff in Excel. So I will either write the reports like in Salesforce, so I know what it is that I'm looking for, and then use that as almost like a roadmap to figure out what fields I have to pull in and how it's supposed to be formatted. It just seems to be an easier way, or an easy way, to figure out what the right syntax is in SQL, or in my case in DAX.
Yeah, I go to Excel still all the time. I'll just pull a bunch of data and see what all the records are and export it into Excel. And I might do a little exploring in Excel, just like see what the column values are.
Yeah. And it just sort of helps to sanity check too, to make sure. Sometimes you write these things and you're like, I have no idea what I.
It can be hard in SQL I find it hard in SQL to write all the queries that you need to check everything that you need.
Yeah.
So
anyway, just some 2 cents.
Usually my process, just to mirror that, usually out of a database, I'll know that it's probably either not clean data or not the format I need. So I'll run the query for the data I need, just like that. I'll export it into Excel. Sometimes it's still messy enough that it doesn't import or export that well to Tableau. You might do a little bit of work or exploring in Excel, figure out what formulas or what formatting you need, and then import that into Tableau to create like calculations and do the final stuff that you need. And then once you've done all that, you have all of your logic and rules and what you need to do to write all of it in SQL. And then oftentimes, once I find all those rules, that goes into a view. I'll create a view like we learned about in the second class. That is just a view over top of it that has all these cleaning and business rules in it. So when you run that view on that table, it returns those clean results as you want them.
Yeah. Any tips and tricks are always helpful.
I think I spent a bunch of years as an analyst, so I think everybody will have their own process. Some people just run it through Python and do that. They just run it through the code and have their own process. But I kind of like to be hands-on with data a little bit, because I think one of the big parts of being a data analyst is like really understanding the data. getting into it and understanding the values and everything.
Yeah, 100%.
Not that you can't do that in Python. It's just whatever your preferences are. Like I started in bank finance, and everybody in banking still uses Excel. So, I mean, they use some other BI tools too, but especially then everything is in Excel. So I'm just kind of used to it. I can do it really fast and have a process more or less and be able to flip through it really fast and write those rules that I need.
Yeah.
Now,
Good times.
even have an AI assistant, you can feed data. I do this all the time, feed data into it, CSV file, and ask it to write a cleaning script for me. And it doesn't always do it perfectly, but like it saves me a lot of time. Generally, you look over it, see how good it is, see if there's anything that's missing, and then just update the script and go. So it has saved me, AI saved me a ton in cleaning data and writing scripts. This is often part of your transform step. People learn that in data engineering, but after you get the data, extract it, you transform it the way you need it. Then you load it into a tool or a system or whatever it might be. But still valuable because I would often still formalize the rules in SQL if it's in a relational database. So really good point. Great data analysts think alike, I guess. If I call myself a great data analyst, I don't know.
Yeah.
Data analyst.
Really just being curious about it is what makes a great data analyst.
Yeah, I agree. Understand you get to learn a lot about business too and systems and process because that's part of cleaning up this data.
Yeah.
Doing what you need for analysis. You get to ask a lot of questions. I always have go on too long because I give everyone a break, whoever wants to stay. But I have one student, she's always like, man, I really just wanted to learn all this stuff. She's taking my data engineering class. She's like, I really wanted to learn all this stuff so I could just sit at a desk and write code. And I'm like, you might be able to do that in a couple of tech positions, but this data isn't really one of them. Like, you're always like having to like work with a developer to figure out why something is, or work with a business user to figure out like why they entered values in a certain way and like how you would clean it up and do things. You're always communicating with people one way or another, even if you're the expert of a system. You're still working with them to say at the end of the day, like, what information do you need from this system or multiple data sources or whatever. So it'd be still nearly impossible to just sit behind a computer all day and do this.
Yeah, that's hard, I think.
Unless you're just writing code, unless you get the opportunity to just write code all day, which some days you do, but not always. Those are the best days. I'm just kidding. This is also a people job a little bit. All right, I'll let everybody take a break while I try to get that example up and try to see if I could get everybody a good update on that, the PowerPoint code, the lecture slide code from all the lectures. I'm going to take a quick walk here too, just for a couple minutes and stretch. I'll be back in a few, maybe just after 7:45. I'll try to be back and see you then. I'll be back here in a couple minutes. Just working on these things I talked about. Let's see, where is... Come on, download window. How's this look? I don't really hear that that knocking sound. It was just when they run the heat in this building. And so just sat down right underneath of it. And now the building's warm. No background sounds, good. Peaceful. I kind of like the little hum or the rattle. I don't know. Probably just me. This looks pretty good. Okay. I think this file will work. I'm going to send everybody an updated combined SQL lecture file or combined SQL file. Actually used ChatGPT, and I put all my lectures in it in PDF format and said, will you update this SQL file to match the slides and the slide numbers in all of these lectures? And it saved me a couple hours. Hopefully it looks pretty good. Sure, it works well. Give ChatGPT's response a try. Just dropped it in the Slack. Looks pretty good. And I reordered. I've changed lecture slides and that PowerPoint's examples over the years so many times that the numbers get out of sync, or I decide to change around slides and stuff like that. I think it looks pretty good. The new file. should contain examples for the new slides that I've created this time around too. Trying to see if I could remember one. Yeah, I did. I can't remember the slides that I added. I added a bunch of examples. Maybe it was the last lecture. Showing examples. But it looks like my file before. We'll go with it and see if we run into anything. I guess I can already see something there. At the bottom of the file, I don't know what that is. Wonder if it imported all of my slide notes too. That's what it looks like it did. You can delete all that stuff at the bottom. I'll clean this file up a little bit. But it gets us back on the, it's kind of synced with the PowerPoint lectures now, rather than the combined SQL or that old combined SQL file. Oh, this thing's long. What did this thing do? That's what happens at ChatGPT is sometimes these things that or Claude, it'll overdo it, or it'll just go off the rails a little bit. And the complaint that I'm hearing from people with AI, it's not using AI. It's not that AI isn't cool and generates this stuff because that's really neat. But now they spend time, they say they spend more time checking the output than if they would have just done it themselves. Because now most of your time spent like checking it and then correcting it. But I'd still challenge, like, it takes a bunch of time to create stuff. And then you have to proofread it on top of that. And then you might make mistakes. So I would say that you probably still save time anyway, but some people would fight me on it. The other thing I was going to do, I was going to generate that example. Okay, we were going to do finding duplicates by row number. Let's just show you what I do. A whole bunch of conversations in here. Yeah, ChatGPT 5. I'm in here. It's pretty recent. Yeah, I have a couple weird things in my search, so I'll just keep it on this one. Let's see, generate. I'm just going to prompt it, generate. You can do it on your phone. I don't think that they have a ChatGPT 5 desktop. Anthropic and Claude does. I use that desktop quite a bit. I use a combination of Claude and ChatGPT. I use Claude for coding mostly and analysis. It's better at that than I use ChatGPT for everything else. And sometimes I have them check each other's work too. So I'd be like, that doesn't seem right what Claude produced, ChatGPT. What do you think about it?
Are you saying Claude or Claude?
I know it always says, when I voice translate, it says, it's always thinks it's quad, like quads, but Claude.
Like C-A.
C-L-A-U-D. Yeah, it's really good for writing code. I'm going to do this in ChatGPT. I'm going to generate finding duplicates by row number, generate SQL code to find generate SQL code to find duplicates by row number in MySQL on the world database. Check this out, it just generates it for me. This is actually using a CTE, which somebody mentioned in class. We don't want to use a CTE yet, so I'll tell them not to do that. So like they talk about coders going away and stuff like that, and probably not in the short term anyway, or just anybody writing code, but you still kind of need to like know how to do it a little bit to even know what to tell it. I'm going to tell it not to use a CTE, use a regular query.
You have to be specific about the
Mm-hmm.
vernacular you're putting in there.
What you really want from it. You'll always try to guess. That's what I tell people. And sometimes, well, if you're vague, then it's just guessing just like anybody else would. It's like, well, I don't really know what you want, but I'm going to guess at it anyway.
So be more specific.
Yeah. Be as specific as you can. I say who, what, when, where, and why. Try to define all of those. And you usually get pretty good result. And if you don't get exactly what you want, you could just refine it with another query like I just did. So I said I didn't want a CTE for an example here of finding duplicates by row number. So this is kind of like a analytical function that we'll learn about in the next class. You can do like a sum over like these groups in your code. So and see what, so it's just a subquery.
For our homework, will we have access to this to complete?
I wouldn't worry too much about this row number right here. I can't even get it to work right.
Well, I mean, not this specific one. Like, are we actually creating the?
Nope, don't worry about this one. I just wanted to show it as an example. It's just something that I added here at the last minute today as another way to identify duplicates. So don't worry about that. I won't put this in the homework. But one thing you can do is a subquery. But this subquery is in your, what is this in your from? You do a subquery and you use this function. Basically, for every instance of this grouping, you have ID, name, country code, district, population. It looks for a duplicate. So while it orders it, the row number, so the first instance that I found Arlington, it'd name it row number 1. And the second, it'd be row number 2. So it counts each one of the duplicates of this instance. And then what you would do by using this row number function is this kind of a more complicated piece of code. Maybe we'll revisit it, and I'll revisit it in the next lecture. But it's where if you removed where the row number is 1, it would give you everything. Because because you have to even sort these and everything. So if we went down to Arlington, see, it does the first instance that it finds would be 1. The second instance would be 2. It's just looking at name and country code. And then when you do, it's kind of a fancy piece of code. Where row number is greater than 1, that's taking the result from this subquery and then filtering it out, filtering it to wherever this row number is 2, thus getting your duplicates. And at that, it should have Springfield with 2 and 3. Yeah, it has 2. So the original, the first time it finds it in the database table, it'll give it row number 1, the second time row number 2, third time row number 3. So it's counting it each time it finds a duplicate. And then anytime it's counted it more than once, then it says it's a duplicate and returns it in a result. So kind of a fancy piece of code. I'll revisit this because we'll do some Windows in the advanced class on Monday. We'll do some Windows functions like this for analytics, how to use Windows functions and what this is doing, because they are useful. And I've never decided to teach it until I started teaching it in a data engineering class and thought it was a better fit here. All right, let's finish this lecture up. Try to get to some examples. This last case statement is actually going to be a pretty decent example of putting everything together. Okay. Let's go ahead and get started. Formatting in null functions. So instead with formatting in null functions, it's all about how do you want to format your numbers, your strings, what part of the substrings do you want to get? Do you want to trim them, format them a certain way? And then you could also do these formatting functions on things like dates, numbers. What else could you format? You can format decimals into money and stuff like that. So there's like currency. So there are a number of different formats you can do. Think of it as like when you're in an Excel sheet and you're formatting a column and it's not in the format that you want it, so you can choose the format that you want it to be in. I think it's similar. And then there's some functions here where you could create a new column in Excel. But let's cover some of these most popular ones. So these are the ones I use by far the most for strings. So concatenate, that's just joining or taking 2 text values, combining them into 1. So you have the first one and the second one, you concatenate them and so that they're both together. First name and last name would be a good example of that. You get the length of a string function, which can help you know how long it is. And then you could use a substring function to get strings within, substrings within, maybe it's the third and the last position or the third and the 7th position. You can do a lot with the length. You can use the left function. I think we use that somewhere else in class. But you could get like the leftmost 3 characters in a string. I don't use the replace function a ton. I usually use logic, but you could find anywhere where there's a substring and then replace it with another substring. Like, I'll see an example of it. Substrings, finding substrings in text, trimming it. So if it has extra spaces at the beginning or front, it gets rid of those extra spaces. Like I said earlier in the lecture, even if it has 1 extra space at the end, the names could be Timothy, one with an extra space at the end, one not. The computer's going to treat it like it's 2 different names. And then format. We'll see how format function works. That also works on numbers. Oh, we have control flow functions. Learned about case statements. That's your multi-step logic functions that you can create. I use those all the time when cleaning up data, like putting in a bunch of rules to clean up data. And then you can use if and if null functions. Those are like single functions that are also useful. It's like if this condition is true, then do this, else do this. Or if that field is null, then just fill this value in for it. So those are useful when finding or filling in, or just simple if-then statements or filling in null values. You have date and time functions, so you can get system dates. So you can ask the MySQL database what year it is, what day it is, what time it is. You can use day month functions to get the date month year out of a date that's in different formats. If you have it in the date format in your database, take the difference between two dates. So you can do the date difference between now and, or like, 19, this day in 1993 and now, and it would give you the number of days. Just thinking of 1993 with the Chiefs. Date add, so you can add days to the current day. So if you added 3 days to today, you get 11/8/2025. Very useful in where statements. You'd say the date is between date, and you could do a subtract. You don't have to do an add. You could do current date and date -3. So you get everything within the last 3 days. And then you could say now, and you get the date and time, or you get the time right now. Comparison functions, coalesce will look at the first null value and then fill it in. We'll see that function in action. Did that again. And then your is null function. So it looks at, it's just a true or false statement if null is a column. I usually use is null in combination with case statement. I'll use the is null function inside a case statement to see if something is null, potentially as one of the rules. Mathematic and numeric functions, in a way, these are also formatting in the sense, maybe you want to round or truncate a number. Maybe you don't want the decimal number. Maybe you want to round it. Ceiling or floor, you go to the next highest or lowest integer, and you can format it in different ways too. There are a ton of formats. One of them, you could take a decimal and format it into currency. In data types, your cast is like your all-purpose. I have a column. I want to cast that as a different type of data structure or a data type within MySQL database. So you may take that string that has numbers in it and then cast it to an integer. That only works if there aren't like letters inside of that field. If it's all numbers, then you could cast it like that. And we'll see that in action. Okay. So numeric, we'll do some comparison functions here and then do an example. So formatting, you can do a number that's in decimal, and this would say format it to 3 decimal places, and you would get this number. So you'd do a number n, you'd format it like this, rounded to d decimal places. And it puts commas in there and everything. So this is often, like, formatting functions are often useful for like a report. If like, so you don't have just a bunch of numbers, it makes it easier to see if you have it like commas in it and dollar signs potentially even. So the cast function, we're just talking about that. Or so cast function converts a value of any type in the specified data type, as long as that value is able to be cast it into that type. So their example, you have cast 150. When you have the quotes around it, it's a string. Then you do it as an unsigned integer. An unsigned integer is just any integer without a minus sign on it. It's a data type that can have integers without whole numbers, without any minus signs on it. And this is 150. So it converts that string. It says it doesn't have a minus sign or any letters in it, so it can convert it to 150. If null is the other one, returns a specified value expression if null. So if you have a null value and then 500, it compares the two, returns 500 if that value is null that you're comparing. So let me do this. Let me state this better. So all of these are scalar functions that go through the column one by one. So if it's going through the column and it hits a null value, it will set this to 500. Otherwise, if it's not null, it'll just stay the same value. So instead of this being null, it could be a column that you're doing this for, and any null value that you get, you fill it in with 500. Right. So is null, it returns true or false depending on when the expression is null. Just explain this. So if it's going through a column and it hits a null value, it'll return 1 like it's true or 0 if it's false. I said I will use this function inside of a case statement. So if it says is null, if the column is null, then put this value into it. I just personally like case statements because usually I'm writing a few different rules. This one is like if you find a single null, just set it to 500. Usually I'm writing is null. If the column is null and another field is a certain value, then set it to this value in the case statement. But I use them frequently in it. And then coalesce returns the first non-null value in a list. So this could be multiple values or multiple columns. But say you're comparing like 5 different columns and the first one is null. The second column returns W3 or has W3 schools in that record. Third one is null. Fourth one is example.com. It's going to find the first value from left to right in your column list that isn't null. And then it's going to return that value. So that can be important when, say, I have a column that's blank and I want to compare it against 3 other columns and then fill in that value based on those columns.
Is it case sensitive or do they have to?
Nope, not case sensitive. So this would be these right here in the coalesce. Yeah, case insensitive.
Which one?
Oh, in the coalesce statement.
So it has to be large.
Well, actually, so if this was the value in the column, it would return it just like that.
Okay.
So if it was going through the rows and in that second column it saw W3 schools and it's capitalized like that, it would return the capitalized value. It'd return whatever value is in that field. So like this column would be used like if I was comparing 3 other columns and I was trying to find like the first value that didn't have null to fill in another column. I'd write a coalesce function maybe as a new column. I'd probably do it as a new column in SQL. I'd say the first one of these that's not null, give me that result. And I use that surprisingly quite a bit. Like maybe it's Medicare and there's like there's management levels in it, and you'd say check this one, check this one, check this one. whoever's in the first one is your person you'd contact or whatever. Maybe they have 3 different roles. It's like a hierarchy or 3 different people. And depending on the clinic, whichever one they have filled in is your person of contact. All right. So that's how those can be used. Let's do an example of a numeric function here. Let's do a convert. Let's convert and then fill in null values. Null values are actually really important too when you're doing counts. So if a value is null, but it should really be a 0, you'd want to fill it in as a 0, because if you were to count it, it would count it as 1 instead of counting it as 0 in your total counts. So knowing whether it's either should be null or 0 is important. So let's go ahead. Numeric function. So let's just run. I'll put a comment on this for now. Let's just see what this looks like. And okay, so you have all these countries. You have their old gross national products. And this might be an example of using the coalesce function. You'd say, you do GMP if I wanted like a GMP. You'd say, give me GMP old or give me the GMP new. If the GMP old is new, then it'd go to give you the GMP new because that's the first non-null value. But anyway, don't want to make this confusing. This is what it looks like. It's all these values. There are a bunch of missing values in this field. GMP old. It's all the 2 decimal points. So what this convert will do, it does 2 things. And we'll see how this changes also. So you can convert this. You'll round it to 0 decimal places. So it's going to take off the 0.00 on each one of those. It's going to convert it to an unsigned integer. And we're going to name it GMP old 2. So now this is what it went from GMP old to GMP old 2. So we rounded the number and converted it to an unsigned integer. And you'd say, how did we know that we needed to put these values in here? There are a couple different ways. I know this wasn't working for everyone. But once you start to type things in, it's not working for me at the moment. It'd usually help you out with what needs to be filled in. And maybe it's my network connection or something. But you can also look it up in documentation. It does come up with all the different functions I can use. But here, there are a couple ways you can do this. In the notes, let's go back to that slide. This slide right here. So we were using the format function. And then we have a number, and then the number of decimal places that we rounded to. So we knew that part. well, we did a round and we weren't, hold on. I should be looking at the convert function. We don't have a convert function in here. Hold on. Okay. Anyway, what you can do, I use a convert function there instead of a cast function. What you can find is in the documentation, you can find that, or you can find all the different functions on the MySQL website. Let me bring this up. If you not even sure what function to use, MySQL function reference. And then you can see all the functions and operators. And then they have built-in functions, type conversions, numeric functions and operators, cast functions. Let's see the cast function. So cast and convert are similar, but you could see the cast function and go to convert. And then you could see how the function is used. So like here, you convert ABC, and then they're converting that to a different format. So let's see if I can find a good number example out of all of this, where they're casting this decimal as a year, but we were using the convert statement. Sometimes I don't find all this documentation always the easiest to use. Convert expression using binary, but we were using it in a function. Oh no, but because we were using the round function first. So you do that number and value, and then you choose the data type. I kind of waffled around on that. So you do the expression, and then you convert it using your data type, and your cast is the same thing. So you can find it in documentation, or else I barely look at documentation anymore unless I really need the details of something. ChatGPT can be our friend on that also. You could say, I'll just ask it, how do I use the convert function in MySQL? MySQL, give me syntax and multiple examples. Yeah. I like doing this much better. It gives me non-technical, it lays it out pretty well. It's a lot less technical than the documentation, trying to figure it out. So here we go. Here's a complete guide to the convert function, and then you convert expression, comma type, or for character sets, convert using the character set name. So since we didn't convert that string to a character set, we would use that function there where you would put the column in into the convert, trying to get my mouse back there. We put our decimal number in there, and we even used the function inside of here. Maybe it'd be a column, and you'd use the round function inside of here. And then we said comma unsigned as the integer type. And then they'll give you all sorts of good examples here. just kind of like what we did. You can convert decimals and convert them into those different MySQL column types that we talked about. Converting numbers to strings. You could even take a number and convert it to string. Maybe you just wanted to save it that way in the database. Converting a string to date. So why that's useful is these dates are almost always stored as strings. If you convert it to date, then you could use date functions on it. You can get the year, the month, the day out of it. It's harder when you have it in a date like this. Although you could do it by maybe getting the left 4 digits and then these middle digits and so forth. But converting it to a date makes it easier. Convert string to a date time. You can take that string and then you have a date time format. And then they give real world examples. So to me, this is like so much better than trying to go and look at like this technical documentation. Even for me, who's used to all of it. Anyway, I took a little bit of a detour there. So I'll get back on track so we can finish. I just wanted to show if you didn't know any of these functions or even know what functions existed, you could go to MySQL or W3 Schools or just ask it and like ask it in ChatGPT, say, how can I change this number into an integer? Like what command can I use in MySQL to change this to an integer? And it'll help you out with it. Or it'll give you an example. You say, provide me an example of it. Okay, so we're filling it in. Oh, what in ChatGPT? That's what I would do. I'd just describe it. It's like, it's just like you're talking to someone. Be it say, in MySQL, how can I use a function to convert a decimal to an integer? And then it could give you that. It might give you that convert statement. Likely give you that convert statement. If you just don't know and you just kind of describe it. That's what I also always find useful in ChatGPT is like when I just don't know about something, I'll just ask it a question. It'll guess, but I'm like, it's either right or not. And I'm like, no, I guess I meant this. It really helps out when you don't know what you're looking for also. Okay. So we were doing the 2 parts of this. I got off track because I wanted to show how you would know how to use that function, where you could go to even know where to use convert, and then the parameters of it. So what you needed to enter here, and then you need to enter your data type after the comma. Putting it all together, we first converted this to unsigned. Say we want to do that, but we also want to replace the null values. So you could say name is country. If this is null, then just put it as a 0. I'd actually kind of like to, I'll put it up here. So let's see what this part does when we do this. So the first part, GMP old 2, this is going to convert any of these GMP old values that have a valid decimal value. It's going to round it to 0 decimal places and convert it to unsigned. The GMP old 3, what that's going to do, it's going to either keep that value because it's not null in the column, or if it finds null, it's going to set it to 0 because 0 will be the first non-null value in the coalesce. So let's see, you could even do multiple columns here, but we'll say if you find null value, basically this is saying if you find null values in that GNP old, set it to 0, coalesce it to 0. So let's see what this does. So it does exactly that. So we see GNP old 2. What that does is it rounds it and sets it to unsigned. And what coalesce does, it looks at GNP old. It says, is GNP old null or not null? And it says not null, so we'll set it to that value. But if it moves to Afghanistan, it says, is GNP old null or it has a value? It says, oops, it is a null. So we're going to coalesce 0 because that other one is null. So it's looking for the first non-null value in this list right here to determine if it should set that value or at the very end, if it should set it to 0. So valuable, even you can do that with multiple columns too and compare the values and set your current column to the first one that doesn't have a null value. Okay. I spent a lot of time on that one. Okay, string functions. Let's do this. Yep, that's all I wanted to cover. And then your final data set, if you put them all together, you get that at the bottom. Okay. String formatting functions, you can concatenate. That'd be like a first name or last name. Or in my case, if you took my first name, middle initial, and last name, just put them all together. That's probably what I'd use it for the most, but there could be multiple reasons to do it. Maybe you're creating addresses too. In string, so returns an integer, which indicates the position of the first occurrence of the substring. So if you're just looking for ST within my test string, this may seem like a lot, but we'll have plenty of practice. We'll have practice exercises that we apply all of these. The in string in my test string, you'll look for the first instance of where there's an ST, and then it just counts 1, 2, 3, 4, 5. The first instance of ST is at the 5th position. If it doesn't find it, it returns a -1 value, I believe. Yeah. It'll return a -1. So if it doesn't find it anywhere, it'll say didn't find it is a -1. But if it does find it, you'll do wherever it occurred first. So that might be useful if you're trying to break this into 2 parts. Hey, you want to find the first instance of the whole name string, and it does it at 10. And then you could do like a left 10 to get that. And then you could do a right, how many ever characters are left in the string. You can break it in. It helps you find little parts of the string so you can break it into parts using other functions usually. Or just to say it is included in the string. There's some value in that too. Maybe there's an abbreviation hidden in a string of values. All right. You can trim, which removes it removes strings after removing all prefixes and suffixes from the given string. So we talked about the trim removing leading and trailing blanks in a string, and that's usually what it's used for, but you could also trim. You can also do a couple things with trim, like you could trim just the leading string value from a given string. If you were to trim leading from leading text, you would just be remain with text. And you could do the same with trailing in the same way. Maybe that's useful if you wanted to remove all the misters off the beginning of Mr. Tom Edison or something like that. You just wanted the Tom Edison piece of it. So you could trim that or something off the back end of it. Maybe you trim PhD off the back of the end. All right, so you can replace values. It replaces all of the occurrences of a substring within a string. So it doesn't just replace the first one. It'll replace anywhere that it's found. So if you replace W3 resource with UR, replace the UR in it, it'll search for UR and replace it with R. It becomes that new word. Resource. It's almost the same, but it takes the UR and replaces it with R. I think that can be useful in a case statement too, or if you're creating something, if you will find a substring in it and there's a bunch of errors in strings if it's mistyped, and then you wanted to replace all of them, all the instances of it, that'd be good use for it. Lowercase and uppercase, one of the more useful ones. You can use the L case or U case to convert the characters to all uppercase or lowercase. So in the case, if you convert L case and you have this uppercase string, it's going to convert all of the characters to lowercase. I think this is most useful even when you have mixed lowercases and uppercases within a string, and you just want to make them all the same. It can be useful in that. Who is that coming out? Length of string. I do it like every single same time every lecture. Length of string. So returns the length of a given string. So the length of my last name is the length of 8. Also, it can be useful to use with other string and substring functions, and especially the substring function. So you can make these pretty complex and be able to get a lot of information out of it. So I just removed it. But your substring, so you have your initial string, and then you have your starting character and how many characters you get from that starting character. So imagine if you had SQL tutorial, you wanted to start at the first character, and then you wanted to get the 3 characters after that. It'd just be SQL. But maybe you wanted to get tutorial out of it. So that'd be 1, 2, 3. It's a 5th character. So you'd write this as substring 5. And then you'd want to get the next 1, 2, 3, 4, 5, 6, 7, 8. If you did 5 and 8, that would get you the word tutorial. There are a ton of these functions also, more string functions. W3 Schools is like the most friendly. I go to W3 Schools for examples. You could use ChatGPT or W3 Schools, and then you could get even more of these examples and play around with all these different functions. I'm just like kind of introducing a whole bunch in this class so you're familiar with them. Okay, let's put all of this, start putting like all of this together. So this might look like something I would write to clean up city states into city states or addresses. You could literally write a case statement that's hundreds of lines long for each like little thing that can go, each little rule that goes into it, or cleaning rule, or things that you would find, or how you wanted to classify things. This will do a combination of both. So it's not always necessarily that you're cleaning data, but maybe you want to classify data too. You want to put it in a group. Like you want to start creating state abbreviations and you don't have that information. So you could say things like in string, if text is in string in the district, then label that state as text. Just give it the abbreviation TX. So maybe you're doing a combination of that and grouping states or cities into like a region. It would do like a region state case all the time if you knew what states were in different regions. Okay, so that's where we talk about like cleaning it and organizing it for analysis. So these string functions convert USA city and state names into city, comma, state in world.city. So we have this big case statement, and you can concat the name and the district to create city, state, full. So you're just taking first name, comma, district. You're concatenating those two fields and then the comma in the middle of every one of them as you go down the table. And then the case statement is creating these state abbreviations. So we'll take a step-by-step look of how this works. Okay. What's that if we just did, this code's not even exactly the same either. If we run this. This one's a little bit different because we do city and state full. So what if we broke this into two different parts? Like it is on the slide. So if we just did this first part, let's do name and district as city, state. Actually name it like that. That goes a little bit more with our convention. So we're just taking the name of each city, appending a comma to it, or concatenating a comma, and then a space. We're leaving a space in between the comma before we append the district, which is the state. Then if we did this, if we did just the case statement, we'll name this as state abbrev. We'll just call it state ABV. Okay. So this is going to break it into each one of its parts. And even I like to break this into small parts because eventually you can combine both of these two. So I use a concat name, and then you can do a comma and put this case statement in it as part of the other part of it. So let's run this and see what this looks like. So this is really like putting it all together. And you could do the same with numeric functions. Okay, so we have a city, we have the state, we can cat in this third column called city state, the name and the state. We create this case statement that creates this grouping, and it does different ways of doing that. It just says one of them's just if district is equal to New York, then set it to NY. And then you can do all different sorts of different things. So if the in string is text within that district, then you know it's Texas. It's looking for that string inside there. If it's true on a record, it's going through these one at a time. If it gets to one like this, and then it says in state, the state is Texas, it says, yep, it is true there. Set the abbreviation to Texas, and the case statement stops there. If not, it'll keep looking through these rules. So if the district is equal to Arizona, then replace, here's just a example of a replace statement. If the field district is Arizona, replace that value with AZ. I was going to see if we had any AZ values in here. Here's one. So what this would do is it would take that district, and this is a state abbreviation field. It's the district is equal to Arizona. If it's equal to Arizona, replace it with AZ. The state abbreviation. So it started look for Arizona. That's true. Set the state abbreviation to AZ. Only true on that record. And that's how you would do it. You would look for all of the instances, the unformatted or clean instances, unclean instances, and you'd create a rule for each one of these. So if there's a leading pen from district, if you trim pen from the beginning of district and then equals Sylvania, then set it to PA. These are a little bit of silly examples, but I think it illustrates like what each one of these does. So if you're going through this, you see a state of Pennsylvania, it'll take off the first letters Penn, see if it equals to Sylvania, that's true, and then set that state abbreviation to PA. And then it has a whole bunch of rules. Otherwise, you have this general rule at the end. Just take the two left characters, set them to uppercase, and that'd be city, state, full. Although we see that doesn't always work on a state like Tennessee. So you kind of are coding for, you create a general rule that would mostly work. Like Ohio would work or Nebraska would work. It works with a lot of states to do the left, uppercase the left two, and that would be the state abbreviation. But it doesn't work for all of them, which you would create rules for. It's kind of rules for the different cases, how to handle the different cases that you have for cleaning up data. So that's where if some field is really messy, this thing could be a couple hundred lines long, potentially. Cleaning up all those little instances of those things that can happen. But at the same time, it's still better than going through these one by one and cleaning them by hand every time they happen. Once you have the rules, hopefully they're set and then you don't have to do it again. But there are cases where sometimes these things change or new data comes in or there's new errors or something like that. And then you have to clean and code it. Also, life of a data analyst. All right. Almost there. What do we have left? Date functions. We're running right up to it today. All right, date functions. Get the number of years since each country's independence. I can cursor. All right, so what this is doing, piece of code. Let's bring this cursor up here. So you can do the year of the current date. Like I said, the current date will get the current year from your MySQL database. The current year that is on your computer. So it's like a system date that it can take a look at, and whatever your clock is set to, it'll get that day and year and month and time, or day and month at least, day, month, and year at least. So what's good about this is that it's a date type, so you can use the year function on it, and you can get your current year. All right, so we're going to also handle some nulls in this one. And you can see it in this table, the independence year is an integer. So we're trying to convert all these dates to a year. But there's some null values. So whenever the independence year is null, we'll just say set it to 0. Otherwise, so because we don't know how many years, we'll just set it to 0 when we say we don't know how many years between the current year and the independence year. Maybe they never had an independence year. Otherwise, take the year of the current date, and when I created this is 2019. Subtract it from that other integer. This one would be 1919, so 2019 minus 1919 would be 100 years. And so a couple of things we did in here. We had a date type. We converted that into an integer with the year function. We could use the year function on a date. It converted it to a 4-digit year. That was an integer that we could use to take the current year minus the independence year, which is also an integer. So we converted it, we took it from a date to an integer, and then we used that integer and subtracted it from the independence year to get the number of years. So sometimes it's a matter of getting the date into a format you need to be able to do whatever calculation you need. This is a good example of that if you wanted to get the number of years since each country's independence. So I won't do the code on this to try to get through the rest of it. That one's fairly straightforward, I think. Oop, those are duplicate slides, so that's good. And those are date functions. We have some date. I must have skipped over the date formatting because there's a number of ways that you could format dates. So if you already have your date in a date format, so if it's converted into like a current date, or you took a string and casted it as a date, you can do a number of date formatting functions on it. So your current date automatically returns the date in the year, month, day format. Your current timestamp does the same. Instead of current date, you do a current timestamp, except it'll also return your current hour, minute, and second. It gets to that from the system date and system time. Your MySQL database does, and it'll return it to you. So now if you have a date or a date time, you can use these different functions on it. I must have skipped over this slide by accident, but you can use hour, get the current hour, difference in dates, day of your week. So this is really important. Maybe you're doing analysis on sales by day of the week. You can convert the current date into a day of the week, and your day 2 would be Monday. You have day, month, year functions, and then you have your current date. Oops, that duplicated. But there are also other formatting functions I don't mention here. If you wanted to change your date into a format that's other than year, month, and date, you can do that. And in MySQL, I'll tell you how to do that real quick. And you believe it's a format function, like we saw with strings. So I just say ChatGPT. And it's not even that I don't know it, it's just it's so convenient to do with ChatGPT. What type of date formats exist? For MySQL dates. I'm typing this in behind the scenes and I'm going to pull this up. Supports several date time formats. The standard is year, month, day. And you, instead of format, you actually use the date format. There's a date format function. You put the date type, and then you can be really specific. So there are different characters that you can use to create different types of dates.
So we'll go for the year, month, and date.
Yeah, so these are interesting. So these will have like dashes in between them instead. And these percentages are like the start of the character. So if you did 4 of these, it would give you like a 4-digit year. And the lowercase is probably 2-digit month and date. Let's see if it'll generate some examples for us. Date. Okay, so what can we do? Depending on how you use these percentages, well, the percentages denote the start of the year, start of the month, and start of the day. And then whether it's uppercase or lowercase, I believe makes a difference. Or if you did it even like this, so if you did a %E, a %B, and a %Y, that gives you something totally different. It gives you 5, and then it gives you the calendar abbreviation, and then 2025. And then you have time-only formats. There are a bunch of different letters that you can use here for your full weekday and month. There are a whole bunch of these that you can use. Usually I'd format it like this if it's like if it's a final output of the report. I wouldn't format it until then. You're just formatting it this way as like something that you're going to export to somebody, or something that's you're just going to copy and paste into a report. But here are all the different formats. This would be useful to include in the slide, I think, too. And then combining dynamic text. So you could put text in there first, and then put these wildcards, and then you could say report for November 2025. I know I'm wearing everyone out, aren't I? I'm wearing myself out. This is a lot in this one. But dates are one of the biggest things that you'll work with the data analyst, because it's like run this report between this date or this year or this quarter or these given dates. And then you're going to have to take those dates and oftentimes convert them into a type that you can use. Or maybe you're breaking it down by hour. It's like, give me November's sales in store by hour. And then you parse out the hour of it. But these functions help you do that. Dates are one of the things that you'll work with the most. So final tips for cleaning data. Profile the data first with count and distinct. It's where you could toss it into Tableau, possibly. Or do count and distinct and do a bunch of group bys, so you get a feel for all of the column values, the counts, how many times those appear, and distinct. So instead of a list of 30,000 abbreviations, you can cut that down to the unique instance of each one. You can avoid functions in the where clause. Not sure what that one means. That's a new slide. Null breaks calculations. Handle before mass. So you want to fill in these nulls before you do any calculations, because you'll get errors with some of your math functions when you do. And then if you're doing data science projects, oftentimes it's good to fill in those too, because a lot of the methods you'll use depend on there being values. Test on sample data with limit first. I love doing this instead of running it on a huge table. Just do the top 10 records or top 100 records first. Take a look at those, write some rules, see how they apply to the rest of your data before you run everything. Clean once and then store clean data. So you store it in a view or clean it and store it in a table for other analysis purposes. Then you have clean data. Document all the changes that you make. Some of that documents itself if you create it in views, but any changes or business rules that you apply, it's useful to have documentation for, and then just choosing the right methods for duplicates that we went over. All right, that is it. We do have some exercises. I ran up right up to 9 o'clock today, covering everything. I will have an exercises file for this. I'll just hand that out to everyone so you have examples of it. But we'll handle null values. Finding all the countries in the world database where independence year is null. We went over some of that. Cleaning with case statements. There's a column in there that has a lot of inconsistent values that you can work on. Removing duplicate records and string formatting and pattern matching. I would also, for bonus points, if you put these into a view and store them, that would give you bonus points, because I almost always put stuff like this as a data analyst into a view, so I don't have to constantly rewrite all of these different cleaning rules or like figure out what my SQL script everything is in. So I'll give that to everyone. How'd you go? You're welcome. We did it all together. I'll send everyone these exercises after the class since we didn't get to it.
So
I feel like everyone deserves a good break after this weekend and these last 2 days. We do cover a lot here. It's a high speed week, and it definitely even more than we cover like those first 2 lectures.
So we're supposed to do the exercises and make the view and send that to you as well?
No, these are just practice. They will be included in the homework on Monday. If you wanted to wait till then, I do have some exercises, but they're just practice exercises that I intend to cover practice exercises during class. We didn't quite get to it. So I could send everyone the practice exercises. They aren't to hand in, but we'll have the full homework on Monday.
Gotcha.
So the intent was to get to this today and then do some practice exercises, but we did cover a lot, and we did cover a lot of examples. So it fills in for it a little bit. Everybody ready for sleep?
Yes. Have a good night. Thank you.
It is a lot after a long day, so I appreciate everyone hanging in there. And I said, like, even if you didn't get it the first time, just go and practice these things and do examples, ask ChatGPT, and just stay at it. You'll get it. Ask for help if needed.
Thank you. Have a good night.
Thank you so
You're
much.
welcome, everyone. Have a good night and get some rest. Take care.
Thank you.
Yep. Bye.
Thank you. Bye.
All right. So that is it for this lecture, class 5. This is our applied skills lecture that we had on cleaning data using SQL. Takes all of our knowledge from the previous lectures and applies them to the need for data analysts to be able to identify potential issues, data quality issues within relational database tables, and then be able to remedy them using SQL code. And that is it for tonight. I am Jeremy Bergman, the instructor of SQL101 for Omaha Data Science Academy. And the next lecture, we don't have the slide here, but it will be over advanced functions and SQL queries and methods for analytics. So we're going to take knowledge about things like creating your own functions, doing stored procedures, utilizing temp tables, common table expressions, utilizing all of those to create advanced queries for data analysis, and some Windows functions too. So that is it. Until next time, I'm Jeremy, and we will see you for the next lecture. Have a good night.